I've started early. Never mind, it's only about that 3 seconds. How are you all? I'm Mr. Harris. That's how I am. We are going to be doing some GCSE direct and inverse proportion. My year 10s at my school have got to do this as their home learning for this week, so I thought, what better than to do a lesson on all these things. If you're year 7 or 8, that's absolutely fine. Try and keep up. Feel free to ask questions. Feel free to stop the video, go back, watch again. I'll try and make it make sense to people. If it does, yay! If it doesn't, it's okay. If you're year 7 and 8, you've still got more years to understand it. If you're year 9, 10, 11, this is all part of the Foundation GCSE. So, without further ado, I don't know why there's any ado anyway, but with no more ado, let's get started. Right, so what is direct proportion? If you watched my video from the other day, which was in the year 5 to 9, that had the stuff about recipes, which is a direct proportion also. But it was a different style of direct proportion. So direct proportion literally means one thing is related to something else. The more of one I have, the more of the other. And they're directly related, which means if I double one quantity, I have to double the other. This is why I was using recipes with it, because at that age group and that level, it's all about if you multiply, if you double that thing, you double that thing. If you half that thing, you half that thing. We're today going to look a little bit more about how we can make a formula from it, and we're going to introduce a new symbology. I haven't got a PowerPoint today for this lesson. I've decided to do a lot of it on a whiteboard, just like if I was in the classroom, because I've got some resources I think will be useful to look at. So let's head over there now. I'm hoping you can see all of the question that's at the top of this thing. We're going to be covering all those different things. But in order to do that, it's first of all useful to identify the things that we may not have an understanding of. For example, there might be this symbol. What is that symbol? Well, I haven't talked it to you before. Find K. What is K? Who is K? Why is K? The constant of proportionality. We'd like to know a bit about that. We'll have to do so. And then it says write a formula. Well, how are we going to do that? Everything we're going to do here, and I'm going to talk us through, I'm going to first of all introduce. So here I am in my notes section. First of all, what is this backwards fish? It's a fish swimming this way. Da-da-da-da. But we don't need those bits. It's just that symbol. What it means is two things are proportional to each other. So if I write A backwards fish B, that means if I double A, I will double B. They are directly related to each other. That's all it means. They are proportional to each other. A is in direct proportion to proportion. Sure, is in direct proportion to. I should probably put that 2 down there. It's annoying me. Is in direct proportion to B. Okay? What that means is we can write A equals something times B. Basically, this is true of any time you see the backwards fish symbol, which means that two things are proportional. There will be a formula where A is equal to a number times B. One is directly linked to the other in this sort of sense that if I then double B, I also have to double A. Everything has to change. But we don't normally use question mark. I agree it might be quite logical to use question mark. We use K. K, we are going to bring in and bring out within the same question. Huh? All it is going to do is be a box or placeholder or envelope. So here's my little box with K in it. It's special K. So I can write A equals K times B, and this is called the constant of proportionality. Now, those people who don't like reading, this is a lot of long phrases. What it basically means is K is the letter we use to stand for unknown number until it's known. How? Well, let's imagine this question. I am told A is proportional to B, and when A equals 7, B equals 28. So what I'm going to do is I'm going to use this idea that we have here, where we can say if this is true, then A equals K times B. I put the numbers in. 7 equals K times 28. Therefore, I believe a quarter times 28 is 7. So 0.25 equals K. And the minute you've worked out what K is, it disappears again. This jumps from being the formula with a K in it straight to equals 0.25b. The whole K thing, it appears, we find it, and then it disappears. It's kind of a placeholder until we know the number. I reckon there might be some confused minds. Good morning to everyone, by the way. I haven't stopped and sort of looked at the screen and said some good mornings. Hello, I know Lars is here. I know Nina Hurst Daniels here. I know Savannah's here. Various different people. Well done, those people who are taking part. I am going to now go through this one more time, and we're going to remove all of this. Boom. Da-da. We're, I think, pink for this question. I am told that M is proportional to, choose a letter, Mr. Harris, T. And I'm told that when M equals 45, T equals 9. So, remember, in comes K on some sort of plane. I don't think it normally arrives on a plane, but we're going to bring it in on a plane. And it's flying in to allow us to say that M equals K times T. When you've got direct proportion, you can bring in a K to allow you to write an equation. We then have got these numbers to substitute in. 45 is going to swap with that. K stays where it is, and T is going to swap with 9. But that means we can rearrange this equation. K must equal 45 divided by 9. We do the opposite thing when we're solving. K equals 5, because 5 times 9 is 45. Soon as we know K is 5, it leaves on the next plane out. It's no longer needed because we now know what K is. So the next step is M equals 5 times T, but we don't bother in algebra putting a times. M equals 5T would be the formula. This is what the formula would be from this pink statement here. That makes that formula. Because K arrived, was worked out, and left. Never to be needed again until the next question. Once you've got a formula, you can use it to work out missing information, because what will probably happen, it will say, the follow-up would be what value is M when T is 12? We've now got a formula. If we put 12 in there, we've got 5 lots of 12. M equals 5 12s is 60. So the whole purpose is we've got this direct proportion tells us to do the backwards fish. Bring K in, find it, K leaves, you've got a formula, put the numbers in. Hopefully this makes some sense. And I'm also hoping that the people are able to see exactly what's going on and they've followed it a bit. Because I can go back to the questions. We can now say, write each statement using the proportional symbol. Okay, well, F is proportional to M. That is F is proportional to M. Well, that wasn't too bad, was it? And for the next one, V is proportional to X. V, backwards fish X. Suddenly, hopefully, it's making sense. Write each statement using K. Bring in K. Someone was suggesting in the live chat that they prefer that K arrives on a train this time. So I'm not as good at drawing trains, but we'll do our best. Steam train. Just to bring in K. That's not the best train in the world, is it? Let's be honest. So K is arriving. So we're going to have F equals K times M. V equals K times X. Remember, all you do, you get rid of the fish. It's equals K times. Question 7, done. We are happy, super, super happy. Any questions? No questions. All 8 of you watching. Anyone who's joined this not live, then feel free to put any questions you have into the comments below the video. I'll try and respond to everyone within as quick a time as I can. Last night I went through and responded to any ones that I had outstanding. So here, X is proportional to T. Oh, we know a thing to do that. X is, well, we'll write that with a backwards fish then. X is proportional to T. K's heard about it. K's on his way in. So X equals K times T. And it then says when X is 6, T is 4. When X is 6, T is 4. So if I divide by 4, 6 divided by 4, because I want to rearrange, K must equal 1.5. K can now go again. Get on that next train out of town, please. It's a fast train, this one, because I can draw them more easily. You can leave. So we can write X equals 1.5t. So we've got the statements of proportionality there. We've got K, we found it was 1.5. Find X when T is 10. Ooh, T is 10, is it? Well, let's put that in. X equals 1.5. Notice how when I'm multiplying, substituting a number into a equation, I always use brackets because it makes it very clear that that must be 15, and it reminds us that we've got numbers to be substituted in. All we've done is swapped 10 in for T. So X is 15. We have a value of X. We're working through these questions beautifully. Next one. I think green for this one. X is directly R is directly proportional to S. When directly proportional. Oh, that sounds like a statement that needs to be written there. R is directly proportional to S. It says when R equals 5, S equals 4. Write a formula. In which case, K is going to need to ride in on a horse. I can't draw horses, so this is going to be the best horse in the world. K is ridden on a horse, and he's arrived. R equals K times S, but 5 equals K times 4. 5 divided by 4 is 1.25, so K equals 1.25. Calculator will help you with that. You are allowed to calculate for these. So then R equals 1.25 S. Get away from here, K. You're not needed. Sad K leaves on sad horse. The horse would have his head down now, I think, because it's sad times. And it's eating some things, but K's leaving on the horse now. Okay, so we now put the numbers in. We've got a formula. Find R when S is 7. Or we can put numbers in. We like to substitute numbers in. 1.25 times 7. If you've got a calculator, you can do that, but I'm happy to do that in my head. Of 7 plus 1.75 is 8.75. And we've done this one. So we're working through these questions. I'm hoping it's making sure. Okay, we're coming on a parachute for the next one. Okay, your learning is your learning. I just try and help make it happen. So the next question is going to be orange. The number of pounds is directly proportional. As soon as we see that phrase, directly proportional, we go, P is directly proportional to euros. E. One day, £1 equals £8. They've done it backwards. This is not fair. They've said that £1 is 80 euros. They've said pounds equals K times E. They've said that £1 equals K. Oh no, they've got in euros. Sorry, my bad. They've put in one day, €1 equals 0.8. So we rearrange K must equal 0.8. So we've now got a formula, P equals 0.8 euros. So now, here's our formula. Use your formula to convert 80 euros. Here's my substitute in colour. Pounds equals 0.8 times 80 euros is going to be 64 euros. And we are done. That is direct proportion to a GCSE level. I hope that having lots of colour doesn't put people off. I know some people can be put off by it. Now, we have now covered direct proportion. This is where one thing is directly related to each other. The second half of this lesson is called inverse proportion, and it's where as one thing increases, another thing decreases. For example, they may not be directly related, but if the rainfall goes up, then the amount of rainfall going up, the amount of barbecues sold will come down. They are inversely related. They might not be directly proportional, but let's pretend for a minute they are. The more of one, the less of another. And anything which has this inverse relationship is that instead of them both multiplying up and both multiplying down, it would be that if I double one, I halve the other. If I times 1 by 3, I divide the other side by 3. So inverse proportionality is where we are looking at inverse proportionality is when we're looking at one increases causing the other to decrease. And it looks like this. As soon as you see that y is inversely proportional to x, you don't panic, you go proportional, that's the fish. Y, because he's there, because I said so. Inversely, instead of just doing y is proportional to x, it's 1 over x. We do it 1 over x. Then it's exactly the same as we had before. There's k parachuting in. Y is equal to k times 1 over x. It's inverse, so it's 1 over x. We get the numbers, so let's say when y equals 5, x equals 4. So we get our substitution colour in. 5 equals k times 1 over 4. Now this is the interesting thing. What this is saying is a quarter of k is 5. So actually, to get this to the other side, we times by 4. K must equal 20. And in general, you can always find k for inverse proportion. It will just equal y times x. You can even say k equals xy. I don't like putting times x's. It makes me feel peculiar. So the k is going to be with the two numbers multiplied together. Just remember that as we go into the inverse proportion questions. So the two things I've just taught you there were that when we're doing these questions, I'm going to try and stick to the same colour because I think we'll stick with purple this time. First of all, remember, AB is a constant. Because they are inversely proportional, we can say A is proportional to 1 over B, so the constant is AB. What I would therefore do, I would do a new table, a new column into my row to my table, and I'd say, well, 15 times 10 is 150. So we need them to always make 150. As soon as you do that, this table becomes easy. Oh, well, it must be 20 times by 75. 7.5 even. Notice how I've doubled one, so I've halved the other. That's what I was saying to you earlier. Inverse means you do the opposite thing. Here, 15 times, oh, that's got to be 10. 60 is going to be 2.5. Notice another way of doing this. This, let me just get these arrows out of the way. This is times by 4. But because we're talking about inverse, that therefore has to divide by 4. That's why it's 2.5. I'm going to glance for any questions because I'm aware that I can talk for a while and then people can be stuck on things. So I'm looking to see if there are any questions. Nina, you're absolutely right. I do say K a bit too much. I'll try and cut it down. I apologise. K. We now have 12.5 lots of 12. Again, there are ways to do this. One way is this is divide by 5, so this one must be times by 5. We can always, whatever, if inverse, you can always do the opposites. That's how you fill in that table. Is it direct? Oh, so now we're trying to say, is it direct proportion or is it inverse proportion or is it neither? So, y equals 2x, we've already seen if it's just times, that's direct proportion. So let's look out for the direct proportion first. Y equals 4 over x, that's not going to be direct. X plus, we don't want pluses, so it's not that one. XY, we've just said the constant being the 2 times together, that's not direct. Y equals 8, y over x equals 8 is direct proportion because, let me rearrange that over here, y over x equals 8. So, times by x, y equals 8x. It's a hidden one, it's a tricksy one, but it is true. Not going to say it. I'm going to say it. Okay. Inverse proportion. We've got this one, and we've got this one. Y equals something over x is inverse. Remember, that's what we've said. 1 over the thing, or times them together and get a constant. So those two. And if it's got adding in it, it's nothing to do with direct proportion. No way, Jose. Hose B as well. All the hoses, in fact. It doesn't matter how many hoses you've got. It's no use. Write each statement using the constant of proportionality. Oh, here's a backwards fish. Y is inversely proportional to x. Y is inversely proportional to x. P is inversely proportional to A. Okay, don't mind if I do. You don't appear to have done that, Mr. Harris. Oh yeah, because inversely means I have to do the inverse, so it's 1 over A. They're both done. We're coming to the end. You're doing very well if you're still following the video. And we're on the last one. Last 2 questions, and you'll see we're wrapping up with an exam style question. I'm going to try and make this a bit bigger so people can see it. Y is inversely proportional to x. As soon as you see that, inversely proportional, we can write in our statement here. Y is proportional to 1 over x. When y is 6, we're going to substitute some things in. 6, x is 10. We're going to have to bring in k. Where are you? I haven't run out of transport. Maybe on a jet ski. Who knows? K's driving in a jet ski. He arrives. 6 equals k times 10. But 1 over 10, isn't it? Because it's 1 over. The k arrives and it's y equals k times 1 over x. Now I've put the numbers in. We times them together. We can find out k by timesing the x and the y together. So it's 60. Now it's come in, time for k to leave. We just get y equals 60 over x. You don't even need to put the times bit in. In the equation, you just put the 60 on top. Okay? Write the statements of proportionality. Did. Use the given values to find k. Did. Find y when x is equal to 15. X is equal to 15. Y equals 60 over 15. It's been swapped in. So y is 4. Happy days. Finally, an exam style question. Let's read the hint before we continue. The question has 3 marks. One of these will be for the correct answer. The others will be method marks. Let's make sure we don't just write a correct answer then. Let's make sure we have our working clearly. Inversely proportional. S, backwards fish, 1/t. Inversely proportional. Now we're going to substitute some numbers in. Let's get our substitution colour. Oh no, we're not. K's got to arrive first. I've run out of transport. K's just falling down like a well. It's just going to fall down. Someone's pushed him in. S equals K times 1/t. Put some numbers in. 20 equals K times 1/0.4. But please remember, we can find K by timesing those two together. 20 times 0.4 is 8. So K equals 8. As soon as we know that, he's going to get in his ladder and somehow climb back up the hole on the side. There's a ladder up. We didn't see the ladder, but it was on the side all along. Climbs out of the hole, no longer needed. S equals 8/t. We've got a formula. Calculate the value of S when t is 0.5. S equals 8 over, substituted in 0.5. And just as an aside, if you're a secondary school student, you should remember if you divide by a half, it's the same as doubling. So that's 16. I appreciate for those people in year 7 or 8, this might have been quite complex today. I hope if you're in year 9, 10, 11, 9 or 10, this has been helpful. If you're in 7 or 8, this is preparation. Watch the video again if you're stuck on any of it. Hopefully it's made sense, and if it has, you've learned something, I've learned something, we've learned something, they've learned something. I'm just conjugating the verb to learn. Thank you very much for joining me. I've been Mr. Harris. You haven't been Mr. Harris, because that would be weird. If you've got any more topics you want to do, don't forget you can always email me and contact me to let me know what you'd like me to go through. You can send me an email to school@mrharris@gmail.com. You can also, if you're at my school, you can just send me an email on the school network. If you want any topics covered, I will try and go through them. I actually have a bonus live stream for my school that will be going on at 2 o'clock today. I'm doing a live stream today. What was it I was going to do? I'm doing something on stratified sampling. It won't be long, but it will just be a few questions on stratified sampling because that's what the school are wanting. If you'd like to join in with that, that's absolutely fine. It's not. I'm not exclusive. This is higher tier GCSE. Anyone who'd like to do a bit of that, then it will be appearing later, about 2 o'clock. I've been Mr. Harris. You haven't. Speak to you later.